As Mohan said, I'm an MD PhD by training. My clinical specialization is in molecular genetics and pathology, but over the course of my career, I've sort of worn a number of different hats, and it's sort of followed an eclectic path. So right out of my training, I went into venture capital and private equity for a period of time. Then I completed my training. I helped start 2 molecular diagnostic companies, one in cancer, one in cardiovascular disease. And then I went back into venture capital and private equity for a period of time. And then I came back out of that and have been in a series of companies and focused in various areas from rheumatology to prenatal screening to cancer treatment selection. And most recently, as Mohan said, was at a company called Freenome that's using artificial intelligence and machine learning combined with multi-omics for various applications with an initial focus in multi-cancer screening. But also during that time, I was working as a medical director with CMS, looking at reviewing and assessing these tests for coverage and reimbursement by Medicare, and I've also served on CMS's MedCAC. So like I said, it's sort of been like an unexpected trip, to say the least. So for what I want to talk about was sort of laid out at a high level on this slide. Spent a little time taking a slightly different or sort of related time on just what screening is versus diagnosis, talk about what multi-cancer screening is, a few notes and sort of perspectives that I couldn't stick anywhere else, to focus a little bit on early, what exactly we mean when we say early detection, talk a little bit about at least what is good enough, so to speak, for a test like this, in my view at least, to be useful, but also some of the debates that are going on in the community, the scientific and clinical community, as well as with the FDA, with CMS, and so forth. And then I guess my take about, for lack of a better way to put it, whether we're there yet. So one of the first things to the point that Kevin was making that I really want to drive home to this audience is the difference between screening and diagnosis, right? Because as Kevin said, even unfortunately physicians frequently get this, or I shouldn't say they get it wrong, but I think they still struggle with this sometimes in understanding the differences. And patients, I know in my experience, most definitely do. So screening is, in the case of cancer, and I'm just going to focus on cancer for the moment, but you could, put in any disease you want where I have cancer right now. It's basically testing for a cancer in an individual who has no signs or symptoms of cancer, right? And so a positive screening result means that you may have cancer. That is in contrast to a truly diagnostic procedure or diagnosis where it's actually the confirmation that you do have cancer. So a positive diagnostic test means you actually have cancer. And I just sort of related in an area that I worked in quite extensively that unfortunately I see us repeating many of the same mistakes in cancer screening as was done with these prenatal tests, right? So this was an article published by ProPublica, as you can see, back in 2022, but this really had been, going on for at least almost a decade, or almost before that. And the challenge is that women were getting these prenatal tests that are just screening tests. They were getting a positive result or a negative result, and in the case of a positive result, they were unfortunately terminating pregnancies on the basis of a screening test that was subsequently determined to be a natural and sort of a normal, if you want to put it that way, child. And the converse also happened, where the test was negative, and then they had subsequently delivered a child with one of the conditions that the test was designed to test for. So obviously, there's sort of 2 pieces to this. First of all, there is no such thing as a perfect test, as we all know. And so the challenge is you can have, as Kevin pointed out, sort of false negatives and false positives, even with a very good screening test, and even with a very good, a diagnostic is a little bit, probably shouldn't really talk about it there, because it's really with a screening test. But then the other problem is the fact that even a very good screening test, is just a screening test. It does not mean you actually have the disease. So it's really important to keep the distinction between these 2 in mind. So multi-cancer screening is, what it sounds like. It's basically screening for multiple cancers at the same time. And the desire is sort of obvious, right? At the end of the day, even in 2024, USPSTF, which is the United States Preventive Services Task Force, did not recommend screening for cancers in which they did not recommend screening represented over half of all new cancers that were diagnosed and over half of all cancer-related deaths this year. And so, in 2023. So the other thing that's interesting is a trend that Kevin spoke to, I guess that he was referring to in cervical cancer, but has also been more widely reported because of Chadwick Boseman and various other folks, and that is an increase in the deaths in younger, defined here as under the age of 50, under the age of 50. So that's been happening in the U.S. and I think even more globally as well. As far as I'm aware, other than the example that Kevin gave in cervical cancer, I'm not sure that this has been happening in other cancers that are currently recommended for screening in the general population. And so that brings us to sort of, what cancers are recommended for screening in sort of the general population. And so I'm only using here the USPSTF. You could look at ACS and many of these things will align, but different guidelines and different entities often have sort of slightly different recommendations in terms of either the populations or the frequencies or so forth. But USPSTF, I think it is fair to say in the United States, is probably considered sort of the gold standard. I think they do the most robust analysis of the data, and at least at some level are reasonably independent of commercial influence, but certainly not wholly independent of such commercial influence. So they have a grading system, and you see that grading system, on the right-hand side of the screen, which is, basically kind of almost like regular grades, A, B, C, D, and then there's not an F, but there's an I. But I'll come back to sort of the meaning of those in a second. So what's important to note is that anything that is USPSTF A or B under the Affordable Care Act is basically required to be covered by any payer in the United States, with essentially no patient responsibility. Means that you should not have to pay. It's sort of $0 out of pocket. Okay, so if you're A or B on their list, it needs to be covered. And so the ones that are A and B on the list are the ones listed here, right? Cervical, colorectal, breast, and lung. And I just wanted to share with you, so the populations I won't go through, but I think what's kind of interesting is sort of that fourth column on the percent screen. You can see there's a huge variation in how many people who are recommended to get such screening actually get such screening. The one that's obviously the most abysmal here is lung cancer, where only about 6% of the population that is appropriate for screening actually gets screened. So then what I also want to touch on, though, Kevin also kind of hinted at, if you see at the bottom, is that there were, let me do this. I want to review for a second just what the grades mean, right? So again, an A grade, just to read the words on the screen, it's a high certainty that the net benefit, so balancing harms and benefits, is actually substantial. So clearly those are, at least relatively speaking, clear winners, right? B's are also good in the sense that this is recommended, which means that there's a high certainty that the net benefit is at least moderate. Okay, with C, which is where prostate cancer sits, at least in the latest iteration of the recommendations, but it is actually, I think, being updated as we speak. This is where there is moderate certainty that the net benefit is actually small. And you saw that from Kevin's slide. And I think this is the challenge, is that in general, things that are C mean that this is basically a discussion between the patient and the provider to try to do their own individual balance of risks and benefits. And then D is important because there are actually cancers that the USPSTF recommend not get screened in the general population. And you can see that list includes thyroid, that Kevin had alluded to earlier, but also ovarian and pancreatic, right? And then the eyes are basically, we just don't know enough to say one way or another whether there should be screening in the general population, and you can see that list includes bladder, oral, skin, and testicular cancer. Okay, so rather than talking about sort of, what anyone should want in a multi-cancer screening test, I'll just speak to what I would want for myself or my family in a multi-cancer screening test, right? And I'll come back at the end of all of this and kind of grade where I believe we are with what is currently available, or at least emerging onto the market as it relates to sort of, especially most, sort of blood-based multi-cancer screening. Okay. So high sensitivity, Kevin spoke to this, right? But which basically means you have a low rate of false negatives, but that you need to establish that high sensitivity in what's called the intended use population. So I apologize for a little bit of regulatory speak, but in simple terms, the intended use population is just the population that you plan to use the test in, right? So in other words, if you test or if you establish the performance of the test in a bunch of patients who have already been diagnosed with cancer, that is obviously not the population in which you're ultimately going to use this test. And this frankly, gets to, and what that does is it's very likely, and has been shown repeatedly in the past, to sort of overestimate the performance of the test. This gets to that pretest probability issue. Obviously, the pretest probability of somebody who's diagnosed with cancer for having that cancer is basically 1, right? 100%. They have the cancer. And so the bottom line is that establishing the performance of these tests in that population that you intend for the test to be used in is critical. But the challenge is, of course, that cancer, any individual cancer, is very rare, and even cancers in general, even if you were to combine them, are still relatively rare. And so what that ends up meaning is that you have to do large studies in order to establish what the sensitivity and specificity are. Okay, so as Kevin had said before, my second bullet point is just, obviously you'd also want a high specificity, which means you have a low number of false positives in that same population. Obviously, we can choose whether we include cancers for which screening is currently recommended, given that we have existing screening technologies that are not perfect but perform reasonably well for certainly some of the cancers for which screening is recommended. And so if you include those cancers in your multi-cancer test, I would certainly want to have at least as good, if not better, performance versus that existing test, again, in the intended use population. Because the problem is, I think this is a real concern, it's certainly a public health concern, is that if somebody gets a multi-cancer screening test that includes, say, breast cancer, lung cancer, colorectal cancer, and cervical cancer, and is negative on the multi-cancer test for that cancer, they may walk away with a false sense of security and therefore skip the cancer screening, the standard of care cancer screening that has actually already been shown in many cases, or at least in some cases, to provide mortality benefit, right? To actually extend life and in principle extend the quality of that life as well. So the other thing you'd want to do is the fourth bullet here, which is you'd accurately want to know what kind of cancer it is, right? Again, it seems kind of logical, but there are effectively a few ways you could do this. One is as part of the multi-cancer test itself, and then the other, which is a strategy that's being taken by some companies in this space, is to basically just say you have cancer, right? But we don't know what type it is, or we don't want to make any claims about what type it is. Go get, this will sound familiar, effectively a whole body, or at least some part of the whole body PET CT scan, right? So it's sort of even taking the whole body MRI idea potentially even a step further, right? But it would be nice, of course, if the test itself, the multi-cancer screening test itself, could accurately identify, is it breast, lung, colorectal, or whatever, right? And then to Kevin's point, I certainly would want to know that getting this test is going to help in the broadest sense of the word, that it would actually improve health outcomes, by which I mean not just the quantity of life, but also the quality of that life, because I think both of those things are relevant. And I think, unfortunately, we often end up focused on the quantity and not the quality, whereas I think both are, important and valuable. And then finally, I think it's fairly obvious that you'd like it to be, relatively convenient and inexpensive, because both of those things will go directly to improving adherence with the screening, as well as just accessibility across the population, and especially ex-US to other populations across the world. So a few notes that I didn't really know where else to stick, but at the end of the day, depending upon the classification system that you use, there's over 100 types of cancers, right? So I think it's just really important to emphasize that none of the tests that are either commercially available today or in development are truly universal or pan-cancer tests, right? So I bristle a little bit anytime anyone uses that kind of terminology, especially with patients, because I think it's misleading and frankly potentially dangerous. And then the other thing, I'll at least share a bias that I have, at least based on my experiences, is sort of the obvious point, which is just because we can do something doesn't mean we should do something. And this gets directly to the unintended consequences of some of these tests and potentially turning everyone into a cancer patient, when in many cases, in my view, the goal is not so much as it makes for a great bumper sticker, the goal is not so much to cure cancer, which I think would be wonderful, but may not be realistic, as opposed to turning cancer into a chronic disease, by which I mean it is something that you live with a high quality of life, and not that you necessarily die from, or I should say, die with and not necessarily die from. Okay, so then I want to take a moment to talk about early detection, because this is sort of the lingo of the day. And quite honestly, I will share with you my bias that this focus on early detection is a little bit of a sleight of hand, because obviously we have all learned from a very long time that detecting cancer earlier saves lives, right? It's sort of just taken as fact. And the problem is it's always the devil in the details, right? Because part of the reason why the discussion has gotten framed or termed early detection versus screening, which is what it really is that screening, quite honestly, has certain implications, both from a regulatory standpoint and from a payer coverage standpoint, that the companies want to avoid, and therefore they want to focus on early detection, right? So that's why they're called multi-cancer early detection tests, is a term you'll hear, or MCED is a term you'll hear, because they don't want to use the word screening when they talk about these tests because of what it implies to certain audiences. But the point that I want to make about early detection is that, as Kevin said, the goal of early detection is to improve clinical outcomes. But what you see on the left is basically shows you that what we already kind of know intuitively, which is different cancers are different, which basically means that what is early, meaning what is clinically useful in terms of detecting cancer early, is different for different cancers. And all I'm showing you on the left is a measure that is called the cure fraction, but at the end of the day, just think about it as a fraction of patients who get cured with that stage of cancer. So as you can see, you could get, as in the case of thyroid cancer or something like that, there isn't really much of a decrease across stages. You can go all the way to stage 4 and still have 80% plus survival, right? Whereas if you detect pancreatic cancer or gallbladder cancer or esophageal cancer in stage 2, right? So basically the highlighted section is this stage after which there is the greatest decrease in survival across all stages. And so you see that if you were to detect any of those cancers in stage 2, it's already potentially too late. Whereas with, again, the other cancers that you see near the bottom, breast, anus, prostate, so forth and so on, picking it up between stage 2 will certainly is probably good enough. And even stage 3 may be okay, but obviously you'd want to be effectively to the left of the yellow as much as in the yellow column as much as you can for that individual kind of cancer. The other point that I'll make relatively quickly is that detection is just saying that you can detect the cancer. It's not saying, it's what I would call validity, right? Which just means do you accurately and reproducibly detect the cancer, whereas utility really speaks to whether it is useful to detect that cancer, and that gets to the availability of sort of curative therapy and the stage at which you detect it, right? So this is just another way of potentially saying the same thing, but I just wanted to sort of drive this point home, which is what you need to achieve in terms of sensitivity, specificity, negative predictive values, and positive predictive values is different for different cancers, right? There is not a one-size-fits-all solution here, which is one of the challenges for multi-cancer screening. And I'll just give you, the 3 examples here: colorectal, breast, and ovarian, right? So colorectal has a grade A recommendation for USPSTF for screening. The idea there is you really want to, as much as possible, minimize false negatives. That you confirm it with a colonoscopy, but when you're trying to minimize false negatives, again, what you're really saying is that you want a high sensitivity test with a high NPV, right? Because what comes after it for diagnostic confirmation is a colonoscopy, which is invasive but is relatively safe, right? And then you move over to breast cancer, which has a grade B recommendation. Here, to some extent, it's a balance, right? Obviously, you want as high sensitivity as you get, but you really want to minimize false positives, because effectively there, what you're really doing in terms of diagnostic confirmation is more invasive, but is still, relatively speaking, benign, right? But you still would like a higher PPV there because you're trying to minimize the number of false positives. Ovarian cancer represents, on sort of at the other end of the spectrum, a much different challenge, right? And this is partly why it actually has a grade D recommendation from USPSTF, which means they actually recommend not screening the general population for ovarian cancer, because what follows a positive result for diagnostic confirmation is abdominal surgery. So now we're talking about something that has a very different risk-benefit profile just to establish the diagnosis than, say, colonoscopy at the other end. So here you really would like to have a very high PPV, very high specificity, so there are very few false positives, and you're not sending women unnecessarily to major abdominal surgery. So in terms of the what's good enough, this is the struggle. This is actually a figure from a group called the Friends of Cancer Research that works closely with the FDA, and I was a part of this group that was just talking about the continuum of endpoints and evidence that we're looking at, and where we kind of draw the line for what should be good enough for any of these tests to show to actually get on the market and get sort of robust coverage and reimbursement so that there's widespread access, right? And as you can see, clinical sensitivity and specificity are all the way on the left, and where we want to be ultimately in terms of the evidence is all the way on the right, right? We would like to see, or at least I would like to see, that using these tests actually improves, at a minimum, cancer-specific mortality and survival, and whether that's 5 years or lifetime or whatever, that we can get into this debate. But you can see there's a huge spread in the spectrum between sensitivity and where we actually want to get to, which is, do you improve the quality and quantity of life as a result of the use of these tests, right? And so the question that the field is struggling with is sort of how accurate any of the things that are to the left or in the middle are to predicting the things that are to the far right. And as I said again, whether this is actually different for different cancers, which evidence to date suggests it absolutely is. Okay, so then my final slide, really, so where are we? Or, what's my assessment of where we are? So certainly none of the multi-cancer tests that are out there have high sensitivity, and certainly the ones that are out there, to my knowledge, have not established that performance in the intended use population. In terms of high specificity, this is really what they're shooting for. So not surprisingly, this is where they've set their targets. So they're in excess typically of 99% specificity, but the reason this box is yellow is because none of that has been done in the intended use population, which is a problem, a big problem in my view. Then if you look, the ones that are currently commercially available do include the cancers for which there is screening that is available in the already, and none of them come close to the performance of the guideline recommended screening tests, even acknowledging that some of those guideline recommended screening tests still, are imperfect and have much to be desired. But even given that, they haven't achieved anywhere remotely close to that performance in general. The next part about the accurate identification of the cancer type, as I said, you could there are other ways to establish the identification, the idea of the whole body PET CT, but of course those have their own challenges. But as far as the tests themselves go, they have generally on the order about 80, depending upon the specific cancer type, the accuracy of identifying the type of cancer you have literally ranges anywhere from about 0% up to about 90%, but none of this has been done in the intended use population, which is why that box is yellow for me. Right now, the ones that are commercially available are blood tests, but they're folks looking at urine and so forth. So I think convenience is obviously there. In terms of expense, as you've seen if you've done any online searching, most of these run on the order of about $1,000. So, depending upon your level of disposable income, that may be considered expensive or inexpensive, but certainly for the general population, that is not inexpensive. And certainly none of them have come remotely close to demonstrating that health outcomes actually improve, let alone, again, in the intended use population. And that's it. So thank you very much again for this opportunity, and look forward to the questions.
Girish, your final word and your crystal ball.
I agree. Look, especially given the geography that we live in here in the San Francisco Bay Area, we have a lot of what I call the Palo Alto hypochondriacs, right? So we have people with plenty of disposable income who are hyper-focused and vigilant about their health, and that's, generally speaking, don't get me wrong, I'm probably one of them, right? It's generally speaking a good thing, but I think that, as in many cases, like with Google's new AI that they started using in their search engine last week, and everybody's wondering about what implications that'll have for news organizations who generate the content that Google searches. The technology's in front of our understanding of the science and the biology. So I guess if I have a crystal ball, or I don't know if it's so much a crystal ball as more a desire for us as humanity, it's that we do think about, we pay close attention to the should part of that equation that I shared earlier, and not just the can part of that equation, and try to find a reasonable balance that's not as heavily shaped by commercial interest with what we should do and what evidence is sort of good enough for us to make this something that we recommend to our patients and our friends, frankly. I don't know if that's so much a crystal ball, but that's just a hope and a desire on my part.